will continue discussing together the design of a power supply using Kicad program. Last class, we discussed together the schematic of this circuit. So quickly, we firstly selected our transformer. Transformer was not in the library, so we got it from Mauser or DGK anywhere. Just we downloaded the model of this transformer, so it can now appear in symbol or schematic, or also in the layout. And then we selected our fast diodes here in this circuit. We selected our capacitor. We selected our regulator and another electrolytic capacitor. And by the end, we used buff capacitor or picofarad capacitor with very small value, just in case if you have high frequency ripples. So this is going to be canceled by this filter, this capacitor filter. You find here something else we didn't discuss last class, which is heat sink. Since we have regulator on our board, so we should use heat sink, okay? Because if you are gonna operate this circuit for a long time, for sure you will have some internal losses of the regulator itself. You have the internal heat sink of the regulator, but it may not be enough to dissipate this heat for a long period. So we have to use external heat sink in this case. So what I did is I just looked for a heat sink. So let me open the heat sink. I got it here. So this is the heat sink, guys. So this is the shape of this heat sink, okay? And it's enough to dissipate the energy from one regulator. And this has one pin can be connected to ground, okay? And we can insert our regulator here, okay? So in this case, we have to make our board in order to keep this heat sink laying on the board, and we will make the regulator right angle, 90 degrees after soldering, okay? Right angle in order to connect the two heat sink, the internal heat sink of the regulator and the external heat sink. And there is spring here in this heat sink. This is gonna press all the time on the regulator to keep the heat sinks connected together. Also, guys, one important note here, if you have external heat sink and internal heat sink, we do prefer to use what's called compound material. So the compound material is a thermal material that is going to fill the spaces, any empty spaces between any heat sinks. This to avoid any hot spot or hot air between the two heat sinks. Other than that, it may burn your transistor or your regulator here, okay? So if you are gonna use external heat sink, you have to add filling material or compound material between the two heat sinks together to avoid any air between the two heat sinks, the internal heat sink of the regulator and the external heat sink, which is shown here in this figure, okay? So I downloaded this and included in the library, like as we made in the previous class, okay? And now I connected the terminal to ground. So regularly, guys, if you have any heat sink on your design, you should connect this to the ground of your circuit, okay? So I connected this heat sink to ground, and now the circuit is ready for making the layout. So we have our connector, we have everything. So the input will be here, the output will be here from this connector, and all elements are exist now in our model. So the next step now is let's go to the other file to make the layout. How can I do that? So you can switch to the other file from here if you just clicked on open PCB in board editor, or you can get it from the main project file. So this is the main project file. So you can open it also from here. So I'm gonna open it from here. So as you can see, this is an empty sheet now, and we need to have all of our components here and start making our layout. So the first step, in order to get the components, let's get the update from our PCB schematic. So how can we get the components? So firstly, press on update from or update PCB from or with changes made. So this button, when you press on this button, this window will pop up and you can now make updates for the PCB. We have no errors, we have no warnings. Okay, so now we can close. And once we do that, as you can see, all of components are coming here in order to be inserted in my board. So I have now all of the components, but the question is, now he arranged the component automatically. Does it mean this arrangement is the best arrangement, or is it right arrangement or not? No, actually, it doesn't affect the if it is correct or not. So what you have to do is you need to rearrange your component. So we have what's called auto fit. So auto fit is going to fit the components, but still it may not be the proper way. So the best way is you should connect your or place your elements on the board according to your understanding of these components. For instance, can you see here, guys, where is the regulator? This is U1, this is the regulator, okay? How this regulator is oriented now, where is the heat sink? This is the heat sink, can you see here? These three straps, this is the heat sink part. So the heat sink part is in front of the transformer. So how can you add your heat sink now? So this arrangement is incorrect. It's impossible to have it like that, correct? And also we inserted our heat sink in this model, correct? And this is our heat sink here. U2 is the heat sink. So can you see where the heat sink compared to the regulator? So this orientation is completely wrong. So we cannot depend on the automatic orientation by this way. What we should do is let's orient the component according to your needs. Okay, now let's rearrange these components now. So firstly, I will start with the regulator. Then this is the heat sink. I'm gonna move these capacitors now and bring the regulator in front of this heat sink. So what will happen now? Here will be our regulator. The heat sink will be in the back side, and we will bend this regulator 90 degrees. Okay, so bending 90 degrees, make it right angle. So now the internal heat sink will be in front of the external heat sink. And now you can connect the or make the spring of the heat sink in order to keep the surface all of the time in contact. Okay, so this is the way. This is one thing. If you would like to move the heat sink or regulator from here, it's up to you, but you have to keep them in contact by this way all of the time in order to keep the heat sink connected to your regulator. Okay, guys? So this is one thing. Let's start arranging other components. So we can even move both of them now anywhere and start arranging our components. And by the end, we can select the orientation of our circuit. So this is our transformer. Here, this is our connector. So let's rotate this transformer like that. So we will have here this connector, and we have the capacitors. So let's bring the capacitors close to the connector here. And we have the diodes and regulator. Let's move this to this part here. And now we have 4 diodes. These diodes can move, for instance, here. And then we will have one small capacitor. This can be, for instance, in this place. What do you think? Is this arrangement good or not? If you'd like to change, it's up to you. So we try to utilize the board, okay? Keep it small as possible, okay? Since you don't have any problem in electromagnetic interference. What the meaning of that? If you have high frequency component, try to keep it away of the transformer, for instance. But we don't have any high frequency here in this circuit. This is just DC power supply. Input frequency is 60 hertz. Output is DC. So we don't have any kind of high frequency here. But if you have transformer or coils, regular coil, along with high frequency element, so try to keep it away. Otherwise, there will be interference between the elements, and this will make a lot of noise in your circuit. Okay, noise, it doesn't mean only sound. Noise mean noise on the pulses you have. It will distort your pulses. It may burn some electronic components. Okay, so this is the meaning of noise or disturbance in case of electromagnetic interference. Okay, so if I satisfied with the orientation like that, guys, let's make now the border edge. So the border edge, we should select firstly the edge from here. So if you go to the right hand side, you will find the, where is edge here? Yeah, this is edge cuts. So I selected the layer of edge cuts, and I'm gonna draw the border of this board. So let's select here this rectangle. So this will be the border or the edges of this PCB now. Okay. Next step is we can reorient some of these components in order to make the connections. We have now two options to make the connections. A first option to connect each track, okay, by yourself. Another option is to use auto route. So auto route, there will be automatic routing for all of your traces. Okay. So in this case, you will not do anything. The program will make the auto routing for your circuit. However, sometimes the auto routing may make some troubles or some problems if you didn't consider this in your rules or design rules. So what is design rules? So if you press on this button here, so this is the rules. So this is the board setup. In the board setup, you will find everything regarding the setup of this board. One of the important things is the design rules here. So let's see the design rules, guys. So these are the rules we have here. You will find that what should be the minimum distance or minimum clearance between two tracks. So here it is 0 millimeter. 0 millimeter may not be good, correct? But the distance here is in millimeter. I'm not sure, guys, if we can change the setting of Kicad to be in mil. What is mil? So we have different, or we do prefer to use different units for designing PCBs. So mil is 1 divided 1,000 of inch. Okay, so mil is 1 divided 1,000 of inch. So this is standard use for PCB. Okay, I'm not sure if I can change this here in Kicad or not. So by the way, this is the first time to me to make a printed circuit board on Kicad. So I used to use other programs before. Okay, but all of programs more or less will be the same. Okay, just very few changes. In other programs, I used Lab Center Electronics. It's called Protos. So Protos, yeah, it's very flexible. You can change between millimeter to mil to whatever, and you can change a lot of things. Here in the setting, I'm not sure if we can do that. Where?
Go to the left.
So close this. Okay, let me close this one now. Here?
On the very left side of the screen. The very left toolbar.
Where this, Ethan?
Right.
The left-hand side here?
See millimeter highlighted. Put the one above that's minimum. Right above this now.
Okay, but this is to draw something or not. Let me check if this is gonna change the setting or not. So again, here, the board setup. Okay, so it changed to mel. Yeah, thank you so much. This is fine. Okay, so we can make this option here, guys. So now we can check the settings in mel. Okay, so 0 mel between two tracks. This is gonna be very bad. Okay, so let's make it, for instance, like 5 mils, for instance. Okay, the minimum track width. Since you are going to make light current, the current is gonna be very small, so don't worry about the track width. When we should care about the track width, we should care about the track width if you have high current in your circuit, because high current will need extra size of the trace, correct? So your trace has to be large enough to carry your current, okay? Otherwise, the track will be burned, or the trace will be burned, okay? So there is a relation between current and trace width, okay? So we are not gonna consider this here since we have very small power. And by the same way, guys, we can make all other settings here. So I just give you an example here, okay? So I'm going to keep 5 mils between each track, okay? We have also net classes. So the net classes here, you will find the rules that will be used in your design. If you consider these rules, you will not have any error. If you didn't consider these rules or break some of these rules, you will have some errors by the end, okay? How can you solve that? You can modify actually these rules. But if you would like to modify, you have to take care about the standards, okay? Other than that, you will make something wrong in your board. You may burn some traces in your board, for instance, okay, guys? So this is very important. So according to your board, okay, if it is light current, if it is high current, so you have to adjust the network or the net list or net classes default setting, okay? And if you'd like to make customs for rules, here you can have code to modify these rules also, but you need to write a certain code here, okay? So I'm gonna close this for the time being. Let me make some traces with you to see how can we make traces, and then we can make the automatic routing. So let's start from the DC part, from the terminals here, guys, of the input. So how can I start make traces? So press on this button here, route, and start following your tracks. So I will start with this 10, for instance, 5 volt. Once you press here, it will give you where is the direction you should go. So can you see? You need to connect to this first capacitor now, for instance. Okay, so this is the 5 volt. So do you think now, guys, this connector is oriented in the proper way or not? I think if we rotate this connector, okay, in this case, the capacitor will be very close to this terminal, correct? But the question is, can we rotate this connector? Where will be the inputs of our wires? So we have to consider this also. So if it is not clear, how can I figure this out? I need to see the component itself. So let's see the component. From where we can see the component, guys? Either from datasheet or from the 3D viewers. So here we have 3D viewer. If you press on view, 3D viewer, so here you will have the 3D components, but unfortunately the 3D of connector and transformer are not available in this model. So we don't see this connection here. But for me, I think this strap here is made for screws or something in the side. Okay, so in order to know, guys, you need to check firstly if it is okay or not. If it is not possible to reorient your connector, it's very easy. Go to the schematic again and change the connection between pins. For instance, let me close now the 3D viewer. Here we connected terminal number 1 to 5 volt, terminal number 2 to ground, terminal number 3 and 4 to AC. So what we can do is, let's go to the schematic again. So I'm gonna go to the schematic from here, and let's go to the connector. This is my connector. So as you can see, 1 and 2 are connected to the capacitor, the DC link, sorry, the DC output. So what I can do is, let's move our connector from here, or delete these wires. Okay, I'm gonna delete now 1 and 2, the DC, and make 1 and 2 as AC. So this is AC. Let's get that wire again. So 1 will be the AC. So let's now delete this wire. So 1 and 2 are AC now. Let's connect the other terminals, ground and VCC, to 3 and 4. So this is ground. This is here the required volt. You can make the connection, or you can make label and move. So now we connected or reconnect the connector again in order to have a better orientation. Save and go again to here. Can you see, guys? Do we have any change? Is it changed or not yet? Not yet. So what we need is update again. So make update. Yeah, now it has been corrected. Okay. So I didn't change the orientation. It's fine. And I made reconnection for my components in order to be easier in connection, for instance. Now, the same may be for this capacitor. So is it good to be like that, or we can rotate it by 90 degrees? So let's rotate it by 90 degrees. Like that. So let's make connections now. So I'm gonna start with the 5 volt connector. So this is 5 volt. Okay, so now what's the color of the track? It's red, correct? What's the meaning of red here? In order to know, we need to check our layer color. So if you go to the layer colors, you will find that this is a front copper. Front copper means the top layer of your board. Now we need to have bottom layer and top layer. Why? Because we have one surface mounted component. So all of these components are DIP. So it has legs, and these legs are entered from the top layer or front layer and will be soldered from the bottom layer. Okay. But we still have one component only surface mounted. So surface mounted means it will be soldered from the top. So it's up to you. You can now move this component to be in the bottom and make all of your connections in the bottom, okay? And have finally a single layer PCB, okay? Or you can make double layer PCB. It's up to you. But since we have only one component and we may not have a lot of tracks, so maybe single layer is fine. So I cannot decide in the beginning. I have to start and see if single layer is fine or not. If it is not fine, so I need to use another layer so I can switch to 2 layers instead of 1 layer, okay? So let's start with a single layer. So in this case, components are placed on the top and soldering will be from the bottom side. So tracks should be from the bottom side. So I'm gonna select now this bottom cover and start make our tracks. So let's move again to our board, select wires. Now let's make the wiring here. So as you can see, guys, the color became now blue, which is the color of the lower layer. So this is, for instance, the first terminal. We need to connect that to another terminal here, which is our regulator. Can we connect now our regulator like that? So let me make it with you and see if we have any problem, if it's gonna make any problem or not. Is it connected, guys? Not connected. Why? If you spend your life here, it will not connect. Can you see? Is it connected? Not connected. Why? Because it's not existing in this layer. Now I'm connecting in the bottom layer, and this component is surface mounted on the top layer. So it's not connected now. So what I should do now, I can switch between the layers. So what I can do, if I'm gonna use the double layer now, I'm going to delete this wire, and I will select, for instance, the upper, or move the component to the other side. How can I move the component to the other side? Let's go here and right click. So should be, there is an option here to move it to the other side. Okay, so change side or flip. Okay, so change side or flip, I'm gonna do that. So as you can see, the color has been changed now, which means this component now has been moved to the other side. Okay, so let's bring this component here. Okay, and make the connections we need. So we need now the wire. So let's connect this. This need to be connected to the ground. So this is the ground. And this need to be connected here. Okay, so let's, in this case, flipping or rotate this. So let me rotate this one. So now it's easier in connection. By the way, if you would like to make the connection more smooth, you can reduce the grid size. So instead of 5 mils, let's make it 1 mils, for instance. So this is gonna make the line move smoothly with you when making connections. And now we can connect the ground terminal. So this is the ground terminal, can be connected here. We have also, this is ground terminal, can be connected here. Here, we need to connect our diodes. So this is the way, guys. This is what we need to do now in order to make all of our connections. Okay, just follow. Oh, sorry, this is incorrect. Just follow the connections and make all of your tracks. Okay. This also will be connected to ground. The AC, so this is going to be connected to the AC. Okay. And continue make all tracks by the same way. One important note here, What is the voltage of the AC side? Or the volt of the AC, the primary AC of our transformer, supposed to be 110 volt or 115, correct? We mentioned before, guys, for the 110 or 115 volt, this is relatively high volt. It's not like 3.3 or 5 volt, correct? So you have to keep a certain distance between tracks. My recommendation is you have already a certain distance between the terminals of the AC, correct? Keep this terminal all the time. So without any calculation, I don't need to make calculations now. Since the designer already made these terminals with this distance, try to keep this distance between the tracks of the AC. So it's almost the same distance here between this line and this drill or via and these lines as well. Okay, guys? So this is the way how can we make our board. Now, how can we make the auto routes? So what I'm gonna do now is making auto route, but if you check your Kicad, if you didn't install the plugins, you may not find these icons in your program. Here you will have some icons here. Do you have these icons, guys? If anyone is opening Kicad now, do you have these icons on your computer? It's not there. So for instance, this icon is called free routes. Okay. In order to get that, let's go to the main program file and go to plugin. And from plugin, you will find some third parties or third party companies. You can install any software. Okay. So I got from here, yeah, this is here, free routing, and we already installed that. So for you, press install, and after that, press apply pending changes. So it will install this program in order to make auto route. Okay. So now, since I already installed this facility, what I'm going to do now is just press on auto route or free routing. So when you press that, another window will pop up and it will load the code. Here you have warning, no problem with warnings. So let's start. So we can now start make the routings. And as you can see, guys, he finished routings. Okay. You just may need to check if you have, or if you are not satisfied with any kind of routings. Okay. For instance, for me, I see this is very tricky. Okay. So for this track, for instance, I can move it like that. Okay. But it's not good for this one, correct? Okay. So what is this line? Let's see what this line now. So this line is connected to another network, is no ground. So what I can do now, I can remodify this route. Okay, so let me delete this route and I will modify it myself. So go to track again, select the copper layer. So I just modified this track. Okay. Do you have anything, any comment, any other comment, guys? For instance, this track also, if you like to modify it a bit, move it a bit away of the bed. Okay, this is fine. Okay. This also need to be modified. I think all others are fine, correct? But here in the auto route, guys, by the way, he used 2 layers, okay? This also. He used 2 layers now, okay? So it doesn't make sense for me now to keep this element on the other side. So let me delete it from here. Not deleting, sorry, let me move it to the other side. So change the side again. So it has been changed, and now we need to reconnect that using the upper layer, okay? So let me rotate it again. And now we can connect this using red color, the upper layer color, and this can be connected to, there is already. So this is ground, and this will be connected to this terminal. So now, guys, we have everything ready. All the connections have been made. If you are missing anything and you don't know, you will know when you make checking for your connections. So if you press here, this is gonna show if you have any missing thing, and then make run DRC. So it will check and let you know if you have any error. Okay. So as you can see, guys, we have 0 errors now. So this means we are ready to generate our files. But before finishing, one more important thing is, most of the time, guys, if you have light current PC boards, we do prefer to have ground layer. So ground layer, especially for relatively high frequencies, is going to absorb any kind of distortion. Okay. So how can we do that? So go to this icon, add filled zone, and start selecting all the board. This is going to be for the copper, for the upper copper, and you should make it also for the lower copper. Okay. So I will start with the upper copper and connect this to ground. So this is the ground. Sorry, this is the ground, and press OK. And start make your filling zone. So just follow the complete board. Until going to the same first terminal. Okay. And you will see like it's hashed now. Okay. It's hatched here. Okay. So this is the upper one. You need also to make it in the lower copper, correct? So make another one now. Okay. Ground and okay. And then, sorry, I should start from here. And when you when you draw the zone, guys, as you can see, the color is black. The color is blue, which means it's in the bottom side now, correct? So it has been hatched in the blue color. So this means now we added a ground layer on both of sides. Okay. Now we can see, firstly, let's save and see our, or let's again make DRC check if we have any errors. Okay, run. So everything is fine. We have no errors. Okay, let's close now. As you can see now, guys, we have ground layer everywhere. Okay. But the question is, we made a ground layer on the AC side, on the high volt AC side. Is it fine? No. Now, this is gonna ionize. This layer is gonna be ionized because of the high volt. This is 110 volt. And the distance here is not enough to make this isolation. So we should avoid this layer in this place. How to do that in this program? Let's create another zone around the AC. So it's opened again, and I would like to keep it no net. No net means don't connect that to any terminal, okay? And should be, instead of solid fill, fill type, solid fill. Where is empty? I would like to make it empty now. Can you see these guys? Is it anywhere here? Okay, it's not here, which means now this option is not available in this program, or maybe I need to look for this option. So how can I continue now? It's easy. Let's modify our layer. So instead of having this layer like that, I'm gonna modify this layer by this way. So this is here to up. Okay, and I will create another layer. So this layer is the upper layer. So I'm gonna select the upper again and select another zone here. So I will start from this terminal also. Okay, and connect this to ground. Let's make both together to see if it is fine or not. So let's make it up to here. Okay, so I finished these two layers. So I still need to modify the lower upper layer to be the same like the upper. Let's make it like that to avoid any overlap in these layers. Now, after modification, let's run again on the DRC and check if we have any errors. So it has been updated. We have 0 errors. Close. Can you see now? We don't have this part filled with copper. Okay, which means the AC is safe now. Okay, so we avoided that AC terminals on the transformer and connector as well. Okay, now this is safe board and we have no errors. Let's check the 3D view now. View 3D viewer. So this is the upper face. We have here all components. This is the regulator. Here we'll have the heat sink, but the 3D model of the heat sink is not available. 3D model of the transformer is not available also. 3D model of the connector is not available. But if you are going to make a package, guys, for this board, you have to consider the height of these elements. Okay, so you can get the heights from the data sheet. Okay, so this is the shape now. By the way, you can remove the components from here just in the view. So if I pressed here, so all the DIP component will be removed. Okay, only the surface mount component is here. See, can you see C3? It's still here. So this can be removed from this button. So I have now the board without any components. Okay, and let me return back this again. So we have now all components. So this is a view. We can flip the board to see the other side. So the other side seems good also for me. And again, this part has no ground layer because this is AC. So I think this board is safe now, and we can go to the next step, which is generating Gerber file in order to send it to be manufactured. Okay, so close, save, and the next step is let's go to file, application outputs, and select Gerbers or all Gerber files. Okay, press here, keep it in default, but you just need to select your directory. So I'm going to select a directory with you. So this is the main file of my project. I'm going to make another file called Gerber. Okay, and I will select this folder to be the destination. Yes. So what you need is just press on plot. So this is done. Then generate drill files. Generate. Done. So you can now close and go to the destination to see the files. So this is the power supply project. And here, this is the Gerber file. Go inside the Gerber file and select every file ends with GBR. So this is GBR, GBR. This is not GBR, GBR. So you will find all files actually are GBR except one file. And next is you need to compress these files in one compressed file. So I'm gonna add this to gerber.rar. Okay, so this is the file here. Now I'll need this file to upload it to the manufacturer website. So let me show you how to do that. So on the manufacturer website, there is one well-known manufacturer website called GLC PCB. Yeah, this is the one. If you go to this website, guys, so you can now add your Gerber file. So add the Gerber file here. So the destination, I already copied the file, so I'm going to paste it here. So it will be uploaded. And when the file uploaded in the browser, you will see the board here. So can you see, guys? These are the two sides of our board. Now we can make manufacturing for these boards. So can you see, guys, what the price of manufacturing this board now? $2. For how many pieces? Actually, this is for 5 pieces. Yeah, what the shipping now? Shipping, this is to the United States, 17.8. Okay. So if I'm gonna do that, I will not order only 5 pieces. Let's make it 10 just in case. Okay. Because for the first times when you start make soldering, you may burn some tracks. Okay. So 5 is fine, but since it's only $2, so shipping is $18 and cost of the PCBs are only $2. So for that, guys, we try to make order with many PCBs. If you have many PCBs, you're gonna design all and send it just in one order. And by the way, if the order reached to a certain weight, it will increase the shipping cost for sure. Okay. So, but here the shipping cost is, I believe it will be $17.8 if the package is less than 1 kilogram. Okay, and the size now or the weight of this package is 0.18 kilogram. Okay. Okay, guys. So this is the way. If you would like even to get the materials used to make the PCB, you can ask to add these materials here. Okay, you can ask for these materials to make your PCB your own if you have a PCB lab or whatever. Okay, guys, because what happened for these companies, they will make a stencil for your board and they don't need it anymore again because this is not a continuous product. Okay, so this has been made only for your board. So if you need it, okay, you can take it. Okay, but you have to pay for that. Okay, guys. So this is from A to Z how to make a PCB and order it. Thank you, guys, and see you next time.